Welcome to EduRef. Today we are going to explore our living, breathing Earth. For centuries, indigenous communities have actually viewed our planet as a mother figure. In India, it's beautifully personified as a living deity, Bhudevi or Vasudha. We aren't just looking at random rocks and water today. We are looking at a deeply connected system where, believe it or not, the southern Indian Ocean can literally influence the monsoon rains all the way in the Gangetic Plains. So here is our lesson plan for today. We've got 1. Mapping our spherical Earth. 2. Exploring the blue planet. 3. Landforms across the continents. 4. Early Eastern India uprisings. And 5. A world geography final summary. Alright, let's jump right into section 1. Mapping our spherical Earth, the cartographer's challenge. So how exactly do we draw our massive curved planet on a flat piece of paper? Well, the first thing you need to know is that our Earth is not a perfect sphere. It's actually what we call an oblate spheroid. Because the Earth is constantly spinning, it bulges at the equator and kind of flattens out at the poles. So trying to flatten our world onto a 2D map, it's exactly like trying to flatten an orange peel without tearing it. It is literally mathematically impossible to do perfectly. Because every map is a compromise, map makers have to choose what they are willing to distort. The Mercator projection, for example, is absolutely fantastic for navigation because it preserves direction, but it wildly distorts size near the poles. I mean, it makes Greenland look as big as Africa, when in reality, Africa is about 14 times larger. That is exactly why we often rely on the Robinson projection instead. It's a brilliant compromise that balances size and shape distortion to give us a much fairer, more realistic view of our world's actual proportions. Moving right along to section 2, exploring the blue planet, our life-giving oceans. I want you to imagine leaving the land behind to plunge into the deep waters that give our home its name. Oceans cover an astounding 71% of Earth's surface and hold 97% of our planet's water. But they are so much more than just water. Thanks to these tiny microscopic organisms called plankton living near the surface, the oceans act as the lungs of our planet. These plankton take in sunlight and carbon dioxide to make food. And in that process, they produce almost half of the oxygen you and I are breathing right now. How amazing is that? As your teacher, I really want you to memorize these 5 great oceans. They aren't just giant swimming pools. They completely regulate our global climate through warm and cold currents. For instance, the Gulf Stream carries warm water from the equator up through the Atlantic, which is literally the only reason a place like the UK stays surprisingly warm compared to other places at the exact same latitude. Then you have the Indian Ocean, which is vital for trade and biodiversity, while the Southern Ocean encircles Antarctica, providing a critical home for penguins and seals. Now, a crucial point here is that the ocean floor is definitely not flat. If we were to dive down into the Pacific Ocean's Mariana Trench, we'd reach the Challenger Deep. That is an incredible 11,000 meters below sea level. Just to put that into perspective for you, if you dropped Mount Everest into this trench, its peak would still be over 2 kilometers underwater. Down there, in complete darkness and freezing temperatures, life still survives. Not by sunlight, but through chemosynthesis, which is basically using chemical energy from the water itself. Beyond those 5 major oceans, we have smaller water bodies connecting our world, right? We've got seas, gulfs, bays, and straits naturally carving up the land. And then we have canals. The Suez Canal, for example, is this human-made marvel that opened back in 1869. By connecting the Red Sea to the Mediterranean, it created the absolute shortest maritime route from India to Europe, which completely changed the game for global trade forever. Alright, let's back up for some air. Section 3. Landforms across the continents, from roofs to deserts. Let's surface now and step onto dry land. We'll kick off our tour of extreme terrains in Asia and Europe. In Asia, immense tectonic collisions form the towering Tibetan Plateau. It sits at an average height of over 4,500 meters, which totally earned it the nickname the roof of the world. Nearby, the massive Eurasian steppes act as a vital carbon sink, naturally trapping greenhouse gases. Over in Europe, we find incredibly fertile plains supporting major cities alongside the majestic Alps. The big takeaway here is that mountains like the Alps and the Urals act as massive water towers. Their melting snow and glaciers feed major rivers like the Rhine and Danube, giving fresh water to millions. Let's move down to Africa and South America to see how this builds a picture of a deeply connected world. The Sahara Desert in Africa is the world's largest hot desert, for sure. But get this, did you know that nutrient-rich dust from the Sahara actually gets blown all the way across the Atlantic Ocean just to fertilize the Amazon rainforest in South America? It's honestly mind-blowing. Now, the Amazon is flanked by the towering Andes Mountains, a major conservation hotspot. Further south in Chile lies the Atacama Desert. It is so dry and Mars-like there that NASA uses it to test their rovers. Tragically though, this beautiful landscape is currently facing a huge environmental emergency. It's becoming a massive dumping ground for discarded clothing due to the rapid rise of fast fashion. And this perfectly illustrates the crazy diversity of our remaining continents. In North America, the Colorado Plateau gives us the stunning Grand Canyon, while the Rocky Mountains show us just how delicate nature really is. In Yellowstone, ecologists famously reintroduced wolves in 1995. That single move magically balanced out the overgrazing elk population and completely restored the entire ecosystem. Down in Australia, we find the Great Australian Desert, which has been home to the Spinifex people for over 25,000 years. This brings us to section 4. Early Eastern India uprisings. Geography as a weapon. As your teacher, I want to bridge our geography lesson directly over to history. Let's trace this timeline of resistance in Odisha to see exactly how native terrain was used as a powerful weapon against British colonial rule. When the British began aggressively annexing territories in 1803 and stripping away traditional lands, the local people fought back hard. The Pika Sangram in 1817, led by Buxi Jagabandhu, was a massive people's movement, uniting peasants and local elites. Just a decade later, the Sambalpur uprising kicked off, eventually turning into one of the longest regional resistances in Indian history, stretching for decades and peaking right alongside the Great Rebellion of 1857. So, why did this resistance last so incredibly long? Geography. The rebels, led by a brilliant tactician named Surendra Sai, used their intimate knowledge of hilltop forts and dense, unforgiving forest terrain to wage a relentless guerrilla war. The British military simply could not defeat them in this environment. They didn't know the land. In the end, Surendra Sai was only captured through sheer deception. He tragically spent 37 years in captivity, a massive sacrifice that stands as a true testament to the courage of using one's homeland to fight for freedom. And that brings us to section 5. World Geography Final Summary. Key takeaways for your exams. Let's bring it all together now. Grab your notebooks, class. To summarize world geography, some glimpses. Our planet's varied landforms, from the towering water tower mountains to the deep oceans producing our oxygen, are the engines that control our global climate and our ecosystems. We've seen how human history and trade are tied to these features, and how geography literally shaped warfare in India. But we've also seen how our actions, from deforestation to fast fashion waste, severely threaten this delicate balance, leading to things like coral bleaching and desertification. This is exactly why studying geography is so absolutely vital. We have to learn to manage these resources sustainably if we want to protect our Mother Earth. If you found this explainer helpful, and I really hope you did, it's time to take the next step. I want you to master your subjects. So go download the EduRev app right now.